So what I want to do is run through a few of the projects. We've been doing that kind of broadly relate to how we control erosion and reduce sediment. And I guess principally these relate to the use of vegetation, and that's mostly trees, for mitigating a number of erosion processes. And I guess this talk will provide a broader overview to the one that will follow by Marty Schwartz. So just to give a little bit of context, this work sits in one of the four main work streams as highlighted on the slide there. And while it looks as if the work streams are discrete, as you've already heard today, there's quite a lot of overlap between each of the four different parts, and you'll hear a little bit more about that later on. So what I want to do is cover the things that are listed on the left-hand side, that's over here, that are around that central question around mitigation. Things like, how do we define effectiveness, what works best where, when do erosion and sediment control practices become effective, and how do we assess the performance of particular mitigation measures. I guess from the start, though, it's important we also understand what we mean by the terms effectiveness and performance. So in our work, we've defined erosion and sediment control effectiveness as the extent to which the soil conservation treatment, or ESC practice, achieves that desired outcome. And I guess in determining that effectiveness, we do need consistent and repeatable methods to assess that effectiveness and enable comparisons between different measures. Now, on the other hand, ESC performance, while it's related to effectiveness, is the actual measure of sediment reduction, and it's usually expressed as a percentage relative to a control. However, in common usage, what we find is that people are using these two terms synonymously, but they are different. So one of the things we do as scientists when we begin new projects is to take stock of what is known about the subject that we're interested in. Now, usually this involves us doing literature reviews and producing summary or state-of-the-art publications and reports. So early on in the program, we undertook a significant review of what we know about ESC effectiveness and performance in New Zealand. And then we had that benchmarked against what our international collaborators, pictured here, a couple of them are here today, what was being done internationally, so that we could get a feel for where New Zealand sat in relation to what was going on globally. And those two reports basically provided the foundation for some of the work that we did subsequently. Now, during the 5 years of the program, we also produced several papers, the most recent of which was a retrospective review of tree root research that's been carried out in New Zealand over the last 6 decades as it relates to soil reinforcement and wind firmness. The second significant piece of work that was carried out in relation to this topic was the research done by Raphael Spiekermann as part of his PhD at Massey University, and you've heard some of the technical aspects of that from Hugh this morning. And as you heard, Raphael left us late last year to take up a position with the Austrian Geological Survey. But his work, I think, as you've heard from Hugh, really has made a significant contribution to both the program and to New Zealand. And I think while he can't be with us here today, I'm sure he's here with us in spirit. And as you heard, his PhD focused on the use of trees in pastoral systems rather than on forests. So that's those wide-spaced trees. And what he did, again, as you've heard, was develop those new spatial models for looking at relating landslide susceptibility to the influence of trees in mitigating rainfall-triggered shallow landslides using high-resolution information such as LiDAR. And I guess if Raphael was here, he'd would like to thank the people from Greater Wellington Regional Council who supported him in his work. Now, his thesis and the 3 papers produced from it clearly demonstrated the value of that high-resolution information, as well as demonstrating that such information can allow us to target the placement of trees in the landscape to achieve our soil conservation goals. And if we do this, we can get the benefits at the lowest costs. And Maxim is going to talk a little bit later about costs and benefits in relation to the sorts of work that we're doing. Now, following his PhD, he, along with Tom Mackay-Smith, did a think piece for our Land and Water National Science Challenge on silvopastoral systems. And I think this work has helped fill a gap in our understanding and could be pivotal to how many of our hill country farms become more climate smart in the future. Now, research would not be complete if we didn't generate or try and obtain new data. So one of the other things that we've done, we managed to do during the first few years of the program, was to collect new data on trees and tree roots and how they reinforce soils and reduce sediment loss. So what was quite a significant effort by our Swiss colleagues, a number of them in the room here today, we excavated a number of poplar trees growing at Ballantrae, and we determined their root distributions, and in addition, field pull-out tests were done on the roots to determine their strength and resistance to being pulled out of the soil. So the trees were 22-year-old Veronese poplars in the Nelda trial. That's that funny patterned density trial, as you can see on the photograph there. And that data set has become probably one of the most comprehensive for poplars and has helped underpin refinements in several models. So that information was also recently written up in a journal paper. It was published a few months ago. So all this data adds to our understanding of the role that trees play in reinforcing soils and ultimately in reducing the impacts of rainfall triggered shallow landslides. Now, some of that new data was also collected in related studies that were also supported by the program. These included the silvopastoral work on Kanuka that Tom Mackay-Smith, who's here today, carried out as part of his PhD at Massey University, and the MSc that Ebony Davison did for her MSc. And unfortunately, Ebony would have been here today, but she was sick, so couldn't make it. And in Ebony's study, she looked at survival of poplar material planted at 3 different hill country sites. So Ebony's work for her master's was part of a trial that was established jointly between Massey and Manaki Whenua and the program, and it was aimed at looking at survival, planting techniques, and how this or the survival is linked to different climate variables. And if you want to know a little bit more about that trial, Tom, I'm sure, can fill you in on that. There's 1 year's worth of measurements left to do. I think Tom is currently underway in doing that. So one of the other things we also aimed to do was try and come up with a way to evaluate erosion and sediment control. So in this project, we co-developed an evaluation framework with a range of stakeholders over a 12-month period via online workshops, because we were in the middle of COVID, and a number of people who are here today that were involved in that process. And some of you may have already seen this before, so apologies for that. And I guess where we landed was a 3-part framework that acts as a reminder for what we need to be considering and a kind of process that we might want to follow for assessing erosion and sediment control effectiveness. The left-hand side, that's this bit over here, is basically just a cut-down version of a generic project planning framework that I'm sure you're all familiar with. The top right-hand part focuses on what erosion process is being mitigated and the scale at which its control is considered. But in practice, many, if not most situations, we're not just dealing with one erosion process, we're dealing with a combination of them. And the relative importance of each and or the magnitude of their contribution to sediment delivery to the streams will be the main determinant for selecting the control measures. And you already heard a little bit from Andrew about the contribution from the earth flows and from Ella around the contribution from some of these big landslides. But similarly, the scale in which the control measure is applied is also important, because while you've actually got to do you might want to assess that control measure at some other point. Often it's downstream or it's down the catchment, and so understanding the scale is really quite important. Now, the last part of the framework here is how effectiveness and performance are actually assessed. And we do that by, we can monitor what's going on, we can go out and make some measurements, we can use modeling to run scenario analysis, or we can use some of the grey heads that are around that kind of know where some of those things work and some of those things might not. It's called experience. Lastly, I just want to complete the presentation, I think, by mentioning the range of models and tools that relate to this kind of area of work, and hopefully without stealing anything of what Marcy might cover in the next talk. We also had a PhD student, Faiko van Zadelhoff, who's here. We've, in fact, Manaki Whenua have just employed him on a postdoc, who undertook work similar but different to the stuff that Raphael did for his thesis. So Faiko used a mix of data collected from New Zealand, including the popular data I've just mentioned from Ballantrae, as well as data from other species in Europe. And I guess one of the highlights was that Raphael and Faiko joined forces to produce a paper that's just been published, in which the approaches they took were compared. And what that paper showed was that, and I quote from the paper, the contrast afforded by the two different approaches to slope stability modelling in terms of the assumptions, the methods, and the spatial predictions can increase process understanding, since while each of those processes being different, both approaches are geomorphically plausible. And they further suggested that to increase performance of erosion and sediment mitigation, land managers should prioritise tree planting in areas where the statistical approaches and the physical approaches agree within the high susceptibility classification, which in their particular study area equated to about 8% of their Wairarapa study. So again, this is the idea about, if you have the tools, you can then hone in on the places where you can carry out your mitigation. You don't need to take a sort of scattergun approach. Now, as I mentioned, Marcy's probably going to cover a little bit of that in the next talk. So I'm just going to wrap up now. So what our work has shown is that effectiveness and performance, while related, are actually two different things. I think if you've not heard me talk before anywhere else, vegetation does make a difference, but we got to understand that vegetation, trees, forests, space planting, riparian stuff is not a panacea to solve all the world's problems. In terms of the root data and the stuff we collect and other vegetation, it's really hard to get, and it's also expensive to get. And the data that we have is really limited in terms of both the species and the age profile of that data. Often we only have a few trees of a few ages, and often it's mostly just the young trees. We need data. If you haven't taken from the talks this morning, data is critical. It's critical for the modelling work. It's critical for testing theories and doing things. So we need data to support and develop the theory and the models, but we need that data to calibrate and test our models. Do they make sense? Do they equate to reality? I think in this work, we've come to understand that we need to bring different components of science together to be able to produce the right kind of understandings and maybe the right kind of tools for practitioners. And those tools need to be simple, they need to be easy to use, and they need to be realistic. So a big thank you to our international collaborators, our students, the people that were involved in doing a lot of the hard graft, the stakeholders that were involved in the development of our evaluation framework, and I guess all of whom have helped continue to improve our understanding of how vegetation contributes to reducing the intensity of various erosion processes, and in doing so, reduce the amount of sediment getting into our waterways as well as keeping soil on the hill slope where it can be used productively. And often we're forgetting about that part of the equation. Often we're focused on what's happening in the streams, but it's important that we retain it on the hillside so we can use it. So anyway, that's me done. Thanks for listening.